For today, we're gonna answer a sample shortest path problem. So you decide to plan a navigation route for your college admission in Manila. Below is the visual representation of the directions. So we can see here visual image or representation of the paths from the possible paths from your house up to the university. So for our first question, what is the shortest path from your house to the university? And the second one is, what is the shortest distance from your house to the university? So in order for us to start, we use the Dijkstra's problem. So before doing the actual methods, let us first simplify this illustration by labeling the buildings or landmarks with letters so that we don't get confused later on. So let's start off with our house, which is, we can label A. First taxi station is letter B. The second is letter C. The LRT station is letter D. The university is E. Then going back, we label LRT2 as F. Next is we label the bus station as G. Where do we put it? Right here. Then we label station of the station number 3 of for the taxi H. Then we label the bus station number 2, or the first bus station rather, I. Then lastly, we label the second taxi station from our house J, to make things more easier. Then we connect them. There we go. So now that we have simplified our illustration, let us proceed to the first step of the method we're gonna use, which is the Dijkstra's problem. So first, label the initial vertex as 0. So we can see here that our initial vertex is traced from letter A. So let's just use a different color so we can easily identify. So we label the initial vertex as 0. Second is we box this number, which is a permanent move for the rest of the process. So we box 0. Next one is label each vertex that is connected to the initial vertex with its distance. So we can see that from vertex 0 or in A, there are two possible paths from B or J. So if we would take a look, the distance from the initial vertex up to the they call this the next destination, we can see that J has a distance of 5. So let's just consider that it's the distance from A. Then letter B has 3. So among this, we would identify or determine the smallest number according to our fourth step. So our fourth step is to be able to box the smallest number. So between 5 and 3, we know that the smallest number is number 3. So we box number 3. Next one is, after boxing the smallest number from this vertex, step number 5, consider the distance to each connected vertex. So we would repeat what we did on our initial vertex, which was 0. So as we can see, we have um two different paths, or yeah, we have two different paths. So we have from B to I, let's just highlight this, and from B to C. So we repeat what we did from the initial vertex. So for the sixth step, if a distance is less than a distance already at this vertex, cross out that distance and write in the new distance. If there was no distance at the vertex, write down the new distance. So this means that from B to I, we have 3 plus 2, we have 5. Then from B to C, we have 6 plus 3 is 9. There we go. So we have two different options to take. So again, we just repeat what we did from the first step, or from the initial vertex. So between 5 and 9, the smallest one is 5. So as we go on, we just repeat from step 4, which is box the smallest number until the destination vertex is boxed. So as we go on with identifying each path, we just repeat the same step by determining or identifying the smallest number between the considered distance. Then we box whatever smallest number it will direct its path to. So it's just a repetitive process. So now that we boxed 5, we now consider the distances of 5. So we can see that it's either from I to H, I to G, or I to C. From I to H, we have 7. 5 plus 2 is 7. From I to G, we have 13. 5 plus 8 is 13. Then from I to C, we also have 9. So it doesn't change from what we've calculated or computed earlier. So among the three, the smallest one is 7. So we box 7. Next, we again consider the distances from 7. So from H to F and from H to G. So from H to F, we have 7 plus 6 is 13. From H to G is 7 plus 4 is 11. So just like what step number 6 said, if a distance is less than a distance already at this vertex, cross out that distance and write in the new distance. So in our case, our initial distance was 13. So now our new distance is 11 because 7 plus 4 is 11. So we cross this out and write in the new one. So among the considered distances, we can see that between 11 and 13, the smallest one is, of course, 11. Now, we consider, again, the paths from 11 or G. So from G to F and G to D. So from G to F, we have 11 plus 2 is 13. So we didn't change our initial distance. Next one is 11 plus 4 is 15. So from G to D, we have 15. Between 13 and 15, of course, we have 13 as the smaller value. Next is we consider the distances from 13 or F. So from F to D, then from F to E. From F to E, we have 20. 13 plus 7 is 20. Next, from F to D, we have 18. We cross out this distance. So we cross out 15 because we have our new um, distance. Next, we choose between 20 and 18. So between 20 and 18, the smaller one is 18. So we box 18. Then um for the distance, we only have one, which is E. So from D to E we have 18 plus 6 is 24. So we can see that there are two possible paths. The or there rather there are two possible paths you can take in order to reach E from point. Let's say you can choose from point F or point D. If you choose to go from point F, you will have a distance of 20. If you choose to go from point D or the vertex D, you'll have 24. So we can see that 20 is much more smaller than the distance of 24. So we will consider going from point F rather than from point D. So we will disregard what path we've taken from point F in going to point D. So we'll initially start at point F. So earlier we said, or we've computed that from point F to point E we have 13 plus 7, which is 20. So we'll already consider in this time 20 as the value. So we'll box that one. So there we go. We can see that we've already come up with the shortest distance from or path rather from our house to the university. So let's just highlight this in order for us to get the shortest path. So from point A, B to from B to I to H to G, G to F, and F to E. So we can now answer the question from number 1. What is the shortest path from your house to the university? We can say that the shortest path is from A to B to I to H to G to F, then finally E. There we go. So for the next one, what is the shortest distance? So this only means that we would need to compute for the overall total distance from our house, which is point A, to the university, point E. So we can compute that 3 plus 2 plus 2 plus 4 plus 2 plus 7 is equals to 3 plus 2 is 5. 5 plus 2 is 7. 7 plus 4 is 11. Then 11 plus 2 is 13. And finally, 13 plus 7 is 20. So just like what we've calculated earlier, from E we have 20. We also here have 20. So we can now say that the shortest distance from our house to the university is 20. So that's all for this shortest path problem. Thank you for listening.